This episode of Serverless Chats is sponsored by New Relic and Epsagon. This week, I chat with Aaron Turner about WebAssembly and WASI. This is Serverless Chats, episode number 93. Hi, everyone. I'm Jeremy Daly, and this is Serverless Chats. Today, I'm joined by Aaron Turner. Hey, Aaron, thanks for joining me.
Yeah, thanks for having me. I'm really excited to be here.
Awesome. So you are a senior software engineer at Fastly. So I'd love it if you could tell the listeners a little bit about yourself and your background and what you do at Fastly.
Yeah, totally. So what is it about me? So what I do is I work on a lot of WebAssembly. I've been doing that for about 2.5 years. I started getting really involved in the community. And through that work, I was going to a lot of meetups and things, and I ran into Tyler, who's a CTO of Fastly, and they were working on this new Edge WebAssembly thing. And kind of just the timing lined up, and our interests and both what we're passionate about at the moment kind of did. So I joined the company, and it's been going great so far. And there, what I'm working on is a lot of WebAssembly work, both in terms of like bringing on new languages to the platform, but also just a lot of community work, participating in a lot of events still, doing podcasts and things, and kind of just hanging out with people and having a good time.
Awesome. So I had Tyler on the show not that long ago, and we talked mostly about compute at edge, but we got into WebAssembly a little bit, and I'm finding this whole thing fascinating because I remember way back in the day Java applets and of course Flash, if anybody remembers that. I think that's still around. But this idea of trying to bring compute and more complex applications in a bytecode form, bring those to the browser, and that's sort of a really interesting thing. I don't think it worked out really well in the end, but it seems like WebAssembly is a much more is a better shot at doing that, and I find that really, really interesting. So I'd love to just sort of pick your brain for a little while here and talk about WebAssembly. But I think maybe for the benefit of the audience, why don't we start with what exactly WebAssembly is?
Yeah, totally. So WebAssembly, I like to describe it, or really what it is bytecode for the web, like you were alluding to. And what that kind of means, it has a few implications. Two of my personal favorites are predictable performance. So when you look at something like JavaScript, it's an interpreted language, but we got really good at running it really fast. So we built just-in-time compilers. So what that's going to do is go ahead and read your JavaScript and compile it over and over many times and make some assumptions about what your code is doing, which can get really, really fast if it assumes the right things. But if it makes the wrong assumptions, they can get really slow. Whereas if you're running a bytecode, it's always predictably performant. It's a really bad analogy. People tell me not to say, but I kind of like to think of it as like if you're driving on the freeway, it's kind of like your WebAssembly, like taking the freeway, depending on what you're trying to do, most of the time is going to be faster. There might be some times we're taking the streets, driving around, doing the neighborhood might be a little faster, but 9 times out of 10, if it's far away enough, you might as well just use the freeway. You know what I'm saying? Kind of that little thing. So that's why I like to describe the predictable performance. At least that's how it works in my head. And that's like when kids ask me, or like my little brother's like, what are you doing? I'm like, that's it. And then another thing about it is that it's very portable. So as the nature of the web, it's great for like distributing logic wherever it may be. So both portable in terms of like it runs in all major browsers, which is like a huge solid. That means we can start shipping it. Right. It's very bundleable. So if you wanted to throw WebAssembly into like an NPM package, for example, and kind of use it there, that can run in the background and do some of that predictable performance for you in your JavaScript ecosystem. It's also very language agnostic. So if a parent language compiles down to WebAssembly, the actual bytecode, then you can use any language essentially and have an interface with this JavaScript WebAssembly API. And then I'll get into, it's also very portable in the fact that multiple runtimes support it. So like, for example, right. Node will. It has its own like kind of adapters there. But also people have built their own runtimes for WebAssembly itself, like WASM time, which is a standalone runtime, and as well as what Fastly built, which is called Lucid. And it's an ahead of time compiled WebAssembly runtime type thing. But yeah, that's probably how I would describe it best.
All right, so there's a lot to unpack there, and so what we can do is we'll go through some of those things. But I mean, just in terms of like, I think this is where we look at things that run in the browser, and I know we'll get into this that you can run WebAssembly in more places than just the browser. But running in the browser, one of the things that I think we think a lot about is security. Like, what does it have access to? Can it do network calls? Can it access resources and local resources, things like that? Like, what are the capabilities of WebAssembly?
Yeah, thank you very much for asking that, because it's always like, I'm always like, performance, portability, awesome. And then it's like, oh yeah, there's also these other great things. So yeah, totally in security. The one thing that's really nice about WebAssembly is that it has this concept of linear memory. So the idea really is that you are given a heap, or just like, the way I like to think of it from like a JavaScript background, like kind of self-taught here, is just like, this is one really big array, and you can't go out of the array and you can't go before the array. And like, that's all you can access. And it's sandbox. So because of that, you can't escalate out of that memory and do things with the host. So WebAssembly has a really nice feature in which this linear memory is sandbox, so you can't really escalate out of it, because just the capabilities of WebAssembly don't allow that. And on the topic of capabilities, one thing that's nice about WebAssembly as well is this concept of host calls. So essentially you can say, hey, when we talk about the host here, it can be JavaScript like we mentioned, or one of those standalone runtimes. You're like, hey, host, I know you have access to this function, let's say. I want you to, like, if I call this, I want you to go do this on my behalf. So for example, a common one in WebAssembly that people often use is like, let's say you want to use console.log, for example. You can go ahead and import and say, hey, look, I want to import console.log. And when I call it, I'm going to pass it this value. And then JavaScript can then say, oh, hey, you called this function that I gave you access to, this host call that I provided. Cool, I'll go do some work for you. In this case, log out like a number, let's say, and then let you continue executing. So this kind of opens up all types of cool use cases of like, depending on what the host wants to provide, you can start doing some really cool things and have this security where the user can give you some code that you don't really know what it's doing, but as long as you don't allow it to like, you only has as much power as you will let it have through these host calls, really. And that since that memory is sandbox, they can't really escalate out of there either. So kind of starts to build this like very secure, like we can start trusting code that people are giving us because of these two features,
right?
Which is really exciting.
Yeah. So you mentioned use cases, and I think use cases are probably the best way to sort of communicate to people what the capabilities are, right? So great performance, linear memory, sandbox, security, that all sounds awesome. But if you can't explain what you can do with it, right, it's sort of hard sometimes to visualize. So you mentioned this idea of sort of calling JavaScript or being able to do those host calls and stuff. But like, what are some of like the practical use cases that you would use it for? And maybe even more importantly, like, what's the use case, and then why is WebAssembly better for it?
Yeah, totally. So probably so WebAssembly started off as like, something that's for the browser. It's starting to evolve more into like serverless use cases and things. But just taking a step back where it kind of started, the major use case here was speeding up JavaScript in the browser. So JavaScript kind of is in this interesting place where it kind of had this unwilling monopoly, I will say, on the browser, where like you kind of had to use JavaScript. Right. So because of that, lots of different companies had different interests in it and started pulling it in different ways that it really wasn't never designed for. So WebAssembly kind of was like, hey, look, that whole performance thing we're trying to do with JavaScript, yeah, it's good for that, but like let's take a little bit of the weight off of JavaScript and like give something else. So I bring all this up to say that like speeding up JavaScript really. So if you have like, let's say a loop that maybe it's doing like image blurring, for example, that isn't supported by the browser natively. I don't know if there was a CSS thing proposed, but let's pretend there isn't. All right, but it'll
even
go
if
ahead.
Even if there was, it's not going to work the same way in all browsers, I'm sure. So right.
Yeah, so that's a really computationally intensive. Like you're going to be looping around, like trying to figure out what pixels need to be duplicated, which ones don't. And WebAssembly is really good at those tasks because of that whole predictable performance thing. So what you would do is take that block of JavaScript and instead replace it with a WebAssembly module that you then pass and say, hey, look, here's like the pixels that I want you to go ahead, transform, just return back in your linear memory what the new image is, and I'll go ahead and display that. And that, having access to that predictable performance, then lets you do those things on the browser a lot easier, and they're not so taxing. You can also imagine this same computationally intensive speeding up JavaScript is great for game engines. Like I've seen a few game engines already, like kind of take some of their physics engines and start replacing pieces with WebAssembly modules because it's just built and designed for doing this like computationally intensive math operations and things that game engines really need. And then another one is probably just general business logic. Right. So there's all types of different times where we're just like, hey, we got this like data structure and we just got to make it look like this now for the server. So sometimes JavaScript's good at that, or will be, definitely depends on the use case. So that's one thing I'll note here is that like WebAssembly most of the time works. I'm sure there's that one use case where it's like, okay, fine. But you know what I mean? But 9 times out of 10, let's say we have to take like some JSON. It's huge and we need to like maybe convert like these objects into like an array, let's say. I don't know. I'm just making things up. But you get the point.
I get the
just
point.
That type of business logic where you're trying to like translate things and just stuff that's like really tedious on the CPU. like you can start to put that in WebAssembly modules. And then from the portability too, you can like start sharing it on different platforms, and it's just like, oh, this is really exciting. So yeah.
So I'm kind of curious about this too. Like if you said, if JavaScript isn't fast enough, and a lot of companies sort of have to use JavaScript and sometimes sort of like, make it do something. Sometimes it shouldn't do maybe. So if I'm a developer now, like I love Node on the back end because I love Node because I'm just so familiar with JavaScript that it's just really easy to go back and forth between the front end and the back end using this one single language. And pretty much any time you have to write something for the front end, it has always been JavaScript. I mean, you had to basically do that. So is this something though where if and we'll get into the other languages you can use, could I compile like an entire application, maybe a front end app or what do they call them, single page app or something like that I might write in JavaScript now? Could I do something like that, compile it down to WebAssembly, and then sort of do a similar thing?
Yeah, so that's actually a really interesting question. I'm glad you asked that. So the short answer is no, but we'll get into why. And it comes really down to two different reasons. The first being WebAssembly in its nature is, binary format, depends on strict typing. So like you have to say, hey, I have an i32, I have a 64-bit integer, i64, so on and so forth. JavaScript is dynamically typed. Mm-hmm. And that's part of why we need to interpret it and do that just-in-time thing to figure out those types on the fly. So JavaScript just isn't quite designed to compile down to WebAssembly. And then two, I'll say is that there are some alternatives. Like let's say you want to write like a Rust app that like is like a full SPA. There's a few projects out there that do that. I've seen them on GitHub. I don't know any at the top of my head, but they totally exist. And if that's something you're into, then totally like feel free to do it. But I will make the point that like JavaScript, as we mentioned, it's been being pulled in a lot of different ways. But one thing it sure was designed for was interacting with DOM and building UIs. So right. That's where I think JavaScript really excels, and where you wouldn't really, I would say you really want to like just compile a straight SPA into WebAssembly, because WebAssembly is really good at those computationally intensive things. But SPAs, for example, like, when you see those React demos of like, look, we got like 10,000 triangles that are like rendering every second. JavaScript is amazing at that because we've been iterating on making JavaScript good at that for so long.
Right.
So yeah, does that answer it? Does that make sense?
It does. No, it does.
Cool.
And actually, I mean, to kind of extend that though, there are things that you might want to do in a browser that are fairly, I would say, insecure, especially if you have to do anything with crypto, or you have to like sign a call or some of these other things, call an API that you maybe need to have a secret in that API call, and obviously you don't want that available via your JavaScript by just viewing source. So are those some of the things that you could potentially do with WebAssembly, where you could compile down something that did cryptographical signing or something like that, and then with the bytecode, I mean, would the bytecode could you reverse engineer that bytecode? Could you come back and find the actual source from that, or is that something that might be secure, where you could use something like that to do some of those more complex and maybe things that would add a little bit of security to your app?
Yeah, so that's a really interesting question. I'm glad you asked it. So I will first iterate and say, again, we're talking about that that cryptographic is going to use a lot of math operations, very performance intensive, which makes it a great fit for WebAssembly. That being said, on the security side of things, it gets really interesting because there is a text format for WebAssembly. It's not the same as JavaScript, where you can go and view source and it's just like, oh yeah, this is totally what's running on the page. Nowadays with like mangling and, the translation, it gets kind of more complicated, but WebAssembly is more of a binary format where we can kind of like do some funny things to be like, hey, look, it's moving this memory here and there. But to see the actual source code's a little bit more difficult. That being said, I won't pretend like I'm a security expert, especially in photography space.
I'm not either. So
I've definitely seen like some projects that are like, hey, look, we can make this thing secure with WebAssembly. Here's like our white paper on why. But I wouldn't be able to confidently sit here and be like, oh yeah, totally, just throw secrets in WebAssembly and like no one will ever know what it is. Like, you know what I mean? Right. So I would definitely suggest maybe I could always get back to you about that, or we could do.
Yeah, no, I'm just curious. Like, I mean, I'm thinking through like where are the places where it really fits in, because I think that's a problem. Security in the browser, and with so many people using APIs now, usually, and again, a good use case for serverless is essentially setting up a function that all it does is just adds that secure key or whatever it is, that access token into a third-party API call so that you can just pass it through from your browser. So if you could eliminate that step, you know what I mean, and be able to do some of that, I think that would be that'd be kind of interesting.
Yeah, totally. Yeah, and I definitely agree. Like, for example, whenever we're like importing a bunch of packages, and let's say they're both accessing global scope, kind of just cross our fingers and hope they don't do something they're not supposed to. That is one benefit again about WebAssembly, is that all that sandboxing, that linear memory and things, is that only really has access to what you give it to. So like if I were to have 3 WebAssembly modules, they couldn't go and talk to each other without JavaScript being in between and, hey, you're telling this person that, cool, here you go. Like let's make sure you're not doing anything funny between one another in the current state of WebAssembly today. So, yeah.
Awesome. All right, so let's move on. Let's talk about WASI. What is WASI?
Oh, yeah. So WASI is an acronym for the WebAssembly System Interface. And this is where I kind of like, in my head, WASI is kind of like the node of WebAssembly. I know it's a very loaded term, so please take it with a grain of salt. But essentially, it's a standardized system interface for WebAssembly. So you get things like a lot of like POSIX-like calls, if you're familiar with like a lot of like, we're getting like low level. But you can imagine stuff like great. FD write, FD read, so like reading file descriptors and things. You get those access to those things. So you can imagine kind of like a node, you have like file system, and that's how you would, let's say, generate files on like a server. You use the module FS. WASI kind of like offers that lower level primitive that allows you to do those things in WebAssembly, like create files, read them, and move them around your file system. Which, I'm kind of talking in circles, but I think I get the point.
Right.
So really,
so you wouldn't use WASI though, like you wouldn't use WASI in the browser, right?
So it gets kind of funny there, because there have been some like, you can use things like IndexedDB, if you're familiar, to kind of create a pseudo file system and start to port, like maybe, let's say you want to compile something in the browser. Like if you want to bring a C compiler to the browser, you could use the WASI things and kind of mock out some of these system level resources as like a browser equivalent, and kind of get into this funny world where it does make sense. But WASI itself, one of its goals right now isn't to really be run in the browser, but people are bringing it there. So if you want to, again, like bring a compiler to the browser, you totally could, which is like exciting and really cool. And I think there's a talk by Ben Smith where they did this exactly for their class. They taught like, I forgot which university, but yeah, they made like a C compiled WebAssembly compiler that like took C source code and compiled it. And then there's something else I was going to say about that.
Well, I'm just curious. So then if it's not really for the browser, I get it. Like everybody loves to do those things. Like, can I take this thing that wasn't built for this and make it work in that? But what would you say are sort of the primary like use cases then for using WASI?
So a lot of it is probably like bringing WebAssembly to the server. So, probably for the server, or just even standard command line applications. WASI is really exciting. There's a lot it can do. You'll hear me say that a lot about WebAssembly. There's a lot you can do with it. So really, like I like to think of WASI as like all the kind of benefits of WebAssembly. So that sandboxing that you get, and that host call interface. Because really, what WASI is using is that host call. Just like, hey, like you have access to the file system. Please do what you want with it. So because you get those benefits, there's like an infamous tweet. I know I'm kind of talking, but it's like an infamous, well, not even infamous, that's not the right word, but a tweet that kind of went viral by Solomon Hykes, if you're familiar, the co-founder of Docker, about like how if WASM plus WASI existed, and I think in 2008 is when they made Docker, that they maybe have not needed to make Docker. And the reasoning there is that like, if you could take different applications and compile them down and give them access using like a system interface that's like standardized and have access to things like file system, you can start to imagine this world where you get container-like functionality where you're just like, hey, I'm going to compile my whole app and all of its dependencies down to WebAssembly, give it access to WASI, and they can start to do things and operate in a sandbox way where you don't have to worry about it messing with the parent operating system or conflating with other apps and things like that. And then, of course, we're on serverless chat, so a lot of serverless use case there because WebAssembly is very lightweight and things of that sort. Sandbox, it makes it a great kind of contender for serverless because you can kind of just instantiate a WebAssembly module, start running immediately, and then close it down. And even do things like snapshotting of like the memory and kind of doing saving state and things like that, which we'll maybe get to in the future. There's still some kinks to figure out there, just in general in the whole ecosystem. But yeah, and then a lot of standalone applications. So like we were mentioning, if you want to compile a C compiler to WebAssembly, give it access to WASI and run it on your local machine. Now you can start compiling things on your actual like let's say, the standalone runtimes. If you just wanted, for some reason, give C source code to just a WebAssembly module and have it compiled. Yeah, sure, cool. And I'm sure there'll be use cases for it, because then you can imagine a world where it's like, I want to use the exact same file that I use to, my exact same compiler binary that I use on Mac, Windows, and Linux. I want to like recompile for each architecture and each operating system. So again, that portability. And those are really good use cases I could think of off the top of my head right now.
Hey everyone, I want to take a minute to thank our sponsor, New Relic. Now, some people need dozens of tools to visualize their stack, but not you, because you've got New Relic Navigator, which means you can see your entire system in one place. New Relic Navigator shows you system-wide health at a glance. All your hosts, services, containers, and anything else you can monitor are in one dense hex view with traffic signal colors to give you an instant picture of what's alerting. And you can sort by platform, service, app, or any other tag, which makes it easy to navigate your entire system and see what needs your attention. It's all included as part of full stack observability, so one user gets you access to New Relic Navigator and everything else you love about New Relic. Go to newrelic.com, sign up for free, and start getting answers faster than ever. So, and this might be sort of a stupid question, but the idea of it being sort of like the node of WebAssembly in that sense, where basically that's what it is. It's its own container essentially that can do anything. It can interact with the file system. It's got all of the capabilities, HTTP, networking calls, like it can do all that kind of stuff. And then is that something where and I know the V8 engine is pretty popular with, sort of edge computing and things like that. Is that something where that can run on like a V8 engine, or is there another type of, underlying, container management system or something that would need to run those?
Yeah, so I'm glad you brought this up. So one thing I'll just say as a quick note, so HTTP is still being standardized. So all this is really young. So I wouldn't want someone to be like, oh, HTTP's in there? Cool. All right, let me just close the tab and start writing. You know what I mean? But so there's a lot of standardized APIs still in the works. And we can get into them too if you would like. But to answer your question of like, hey, could you use like WASI inside of V8? Again, we can probably polyfill some things. And then you could totally run it in there in like that JavaScript-y way. But the kind of what gets interesting about that is that even though you can run it, if you can imagine a world where maybe you don't really need the JavaScript as well that V8 provides, then you're kind of like instantiating a JavaScript runtime and a WebAssembly runtime.
Right.
Whereas if you use some of these other runtimes that only support WebAssembly, you get a lighter weight output from it and things like that. So so yes, you can use V8, but it's kind of like, depending on your use case, if you want like to have that solid WebAssembly JavaScript relationship at all times, V8 is probably the right answer. But if you just want to use WebAssembly, then those standalone runtimes are going to be lighter weight and be able to optimize specifically for WebAssembly a little bit better.
Right. So there are standardized runtimes for WebAssembly.
Yes.
Okay. Mm-hmm. That makes sense. All right. So you mentioned some standardized APIs, and we kind of talked a little bit about crypto and how that's sort of a good one to sort of deal with. But you've got crypto, you've got machine learning. All kinds of these complex things that are really hard to do, especially in JavaScript. And again, I know we're now more towards the server side of things. But like, what are those types of? You mentioned they were sort of standardized APIs. Like, what can those do? What are those capabilities?
Yeah, totally. So I will say these are also still in flux, like they're still being developed. But if you wanted to participate, there's totally a community group for WASI that you could totally hop in and join. But this is just me, just kind of like I attend the meetings or have been for a little bit. So it's kind of like sharing some little things that's going on here and there. So yeah, one of them is definitely crypto. A colleague of mine, Frank Dennis, is working on that, where it's kind of like there's a lot of common crypto applications that we would want the host to say, like, hey, like, the host runtime, we know that you're running just raw bytecode. There is no layer between you and the kernel, essentially. So could you please like provide SHA-256 and make sure that it's working correctly and you won't expose the right things? So a lot of like common crypto like functions that people are often using. Like I don't know if SHA-256 is one of them. I heard, you can imagine if you're a crypto person out there, exposing those like common ones that folks use. And machine learning, I'm a little bit more familiar with that because the Bytecode Alliance is a group of different companies that are working together on WASI and WebAssembly and all these specs. And they recently announced they're working on a WASI NN, so like a neural network in WASI, and kind of providing the primitives there of like, if we want to build neural networks on top of WASI, what are some of the host calls that we'll need? What are some of the functionalities we'll need? So we could start to like build our own neural networks
Right.
like in
Right.
WebAssembly, which is really exciting.
So are these standardized APIs? Again, this may be a stupid question just because I don't know enough about this stuff yet, but are those like NPM packages or like Python packages from pip or something, like whatever it is, like is that the idea behind some of these APIs where you say like I need a crypto package or I need a machine learning package or I need an image manipulation package? Is this something where there will be an ecosystem where people can write and contribute packages that other people could just sort of pull in?
Yeah, so this is more like a little level above that, I would say.
Okay.
It's more like it's kind of like you can imagine like temporal, for example, as a new date thing that's coming out to JavaScript. There's already a few libraries out there that kind of like, hey, we're kind of like playing around with this like this new date API. Here's like my version of it and your version of it. But a lot of the community is working together on deciding, okay, well, my organization has these needs for temporal. My organization has these. What are the compromises that we'll need to make for the entire community to have access to this one standardized like API that eventually, for example, like Chrome or whoever's implementing your JavaScript runtime will support natively. You wouldn't have to use a library anymore. So I would say it's a little level above, and I'm sure as these APIs develop, people will develop like, hey, look, here's the current version of WASI in like Rust, let's say, and you can include it in your Rust program that then compiles all the way down to WebAssembly. And so yeah, I hope that.
Yeah, no, I mean, I'm just wondering here, like, I mean, because one of the things that I think makes Node and I mean JavaScript. The reason why those ecosystems grew so much was because people could contribute to those things. So if there's a way for people to do that, and know like, oh, if this doesn't do this now, like I don't have to write this whole thing myself. Like somebody else may have done this for me, and I can just go ahead and bring that in. So So I mean, I don't know if there'll eventually be like an NPM for for WASI or whatever, or for I guess WebAssembly in general. But yeah, anyways, I'm just thinking that would be kind of a cool thing to have. So if there's not one of those things out there, then my suggestion is you create one of those things and make it so that people could could contribute code.
Yeah, so if I could, on that note, like I had mentioned a little bit earlier before it kind of glazed over, is that in the browser at least, like and technically in WASI too, you could ship like just an NPM package of WebAssembly today, and even if it used WASI, like we mentioned, there's like some little polyfills here and there depending on what you want to do. So kind of, I guess, our registry in today's world is probably NPM, and I have seen some smaller WebAssembly package manager type things start popping up here and there, but right now, I think NPM's kind of like the I don't know, for a lack of better words, the king of the packages right now. And we'll see if something else like comes up to, maybe do something that's more WebAssembly focused rather than like JavaScript with the dash of WebAssembly, if that makes sense. Yeah.
Right. Cool.
Yeah.
All right. So let's get into the tool chains here, and maybe we just kind of focus on the popular ones because I'm sure there are a lot of people that are kind of going down this road. But you mentioned earlier that WebAssembly was language agnostic. So what? Yeah. So you can just write it in any language you want, or what? There's got to be some limitations here.
Yeah. So there are some I mean, pretty much the limitation is that is your language like willing to support WebAssembly? So especially if it's like a strictly typed language. So there's like, for example, Go's working on something. Let me think of another, like Swift has a WebAssembly implementation. Zig is an up and coming language that has a WebAssembly implementation. There are some languages where it gets kind of funny. So for example, these dynamically typed ones like JavaScript and Python, they're kind of in a world where it's like, it just kind of, the language doesn't quite line up with what WebAssembly needs when it comes to being compiled. So I mentioned those, but probably the biggest three right now are Scriptin, which is a tool chain for compiling C and C++ to WebAssembly. Yeah. A lot of folks use it. Google, I know, has a lot of folks working on Scriptin, and they kind of highlight a lot of projects using it. If I'm not mistaken, there's a talk from WebAssembly SF in which the Google Earth team talked about how they're using Scriptin to like kind of, again, take all that business logic and make it more portable across where they need to run Google Earth, which is really exciting. Another big one is Rust. I had mentioned it earlier. It's a language that's grown to become quite popular. It's another systems level programming language, but Rust has like a little flavor of both, like kind of taking these older C applications, I guess not really porting, but like kind of building these like one-off modules that like go off and do like maybe you want to speed up your JavaScript, serverless type stuff, whatever it may be. Rust has really started to shine in that area. And a lot of folks are really passionate about it. The community is really cool, and there's a lot of like great documentation. Rust, I guess what I'm trying to say really is that Rust has like really solid WebAssembly support. Like they are like going all in on it, which is really exciting to see.
And maybe I think just thinking back to my things that I've heard. I feel like Rust. Whenever I hear Rust, like I just think WebAssembly. Is that the wrong way to think of it?
Rust does a lot of different things, but it's not maybe the wrong thing just because they've spent a lot of time like really building out a lot of the tooling, a lot of the community around it and things. So Rust definitely also has lots of great use cases that I've seen at like Rust conferences where they run Rust on their server, they do it in games, so on and so forth. It's like a systems level programming language, so you can imagine you can run C there. 9 times out of 10, I think you could run Rust there, but just their WebAssembly and like, what's the right word? Like involvement? There's another word that starts with I that means what I'm trying to say, but they spend a lot of time working on like creating a great developer experience around WebAssembly and Rust.
Yeah.
So yeah, because right now I will say like some languages like Go and things, they're still very young in their WebAssembly implementation. Mm-hmm. So some of the tooling is like, good luck. You know? Right. But I'm sure that will get better over time as more of the community works on it and things. And then if I could transition to, there's one more toolchain that's very popular right now, and it's called AssemblyScript. Yes. And I'm a member of the team on that. And what AssemblyScript is kind of a very TypeScript-like, not TypeScript exactly, but like if you can read TypeScript, the TypeScript-like language that compiles to WebAssembly. So kind of the target there is a lot of these JavaScript developers that, like we mentioned earlier, JavaScript can't compile to WebAssembly. So it's like, come on, we want some of the fun too. So we're hoping to maybe like fill that gap and giving developers the closest thing to JavaScript that we can provide for them that allows them to access like all the benefits of WebAssembly.
Right.
So yeah.
Right. Yeah. Well, so the AssemblyScript thing, because I was doing some research before this, and when I saw that, I was like, okay, now you might have me, because I'm thinking like some of these other things. I spend so much time. I spend a lot of time in Node and in TypeScript and JavaScript. So for me, I was like, oh, this would be really great. So I do have a bunch of questions on this though, and since you work on the AssemblyScript team, you're the perfect person to answer these. So what are the differences between TypeScript and AssemblyScript? Is it almost exactly the same, or are there like some significant things that I'd have to worry about?
Yeah, so one thing is I'll definitely point out is that we mentioned earlier about SPAs, but like just imagine trying to think. So like if you take like a TypeScript React app or a TypeScript Node app, you can't just grab the AssemblyScript compiler and be like, hey, I get WebAssembly for free. Cool. Right. Like that's not how. There's like a lot of like small fundamental differences where you have to like actually take the time to port things, but the porting comes down to like, okay, this number type. Number isn't, again, that strictly type integer of whatever many be bits. So you have to take your numbers and convert them to I32s. If you need to use a float there, you need to specifically say, like, I want to float here, and things of that sort. But for the most part, I actually wrote an article on the Fastly blog about, like, porting TypeScript to AssemblyScript and what that looks like. I think it might even been a JavaScript application, but just kind of like, hey, look, there's this variable here. It's a number. We know that, but JavaScript does the work for us to do that. Let's just explicitly say this is a number. And yeah, pretty much that's like a lot of the big fundamental differences. There are some gotchas too with AssemblyScript. One of them being is that since it's young, it's only about like a 2-year-old language. It's been getting popular though, thankfully. Is closures is a big one. So if you're doing a lot of like callbacks that call callbacks that call callbacks, as of right now, we're still working on like kind of getting that, working in WebAssembly memory and things. So you will have to pull those functions out to separate functions, which is a little annoying, but we'll get there. You know what I mean? And in most use cases, you kind of have that. And then
so in terms of the workflow for some of these things, like I'm writing TypeScript now. I'm going to compile it, right, and then I usually run tests against my TypeScript and then compile it and run the tests. So, like, what is that workflow? Do I have to go from, or I guess I just writing in AssemblyScript, which would be very similar to TypeScript, and then just compile it down to Rust? But how does the testing work and some of that other stuff? Yeah,
so that's actually probably the closest thing. So AssemblyScript is an npm package that you npm install into a project, and you can like scaffold out an AssemblyScript project essentially. Another thing is like AssemblyScript, it pretty much uses the .ts file extension. So if you open up VS Code, it's gonna be like, oh hey, this is TypeScript, and it comes with a TS config. So the TS config will say like, hey, I32 is an alias for number for your linters and things. So you open up VS Code, it's like, oh, this is just TypeScript, cool. It's like awesome. So you can just hit the ground running in that aspect. Like if you're used to writing TypeScript, the amount of like workflow difference should be near nothing to my experience. When you start doing some really specific TypeScript things, or if you have like small things here and there, it gets kind of funny. But some good examples is that even for documentation, for all the AssemblyScript packages I've been writing, I just use TypeDoc. Like TypeDoc can look through AssemblyScript and be like, cool, yeah, like this is this goes there, and like there's almost no actual small things I need to do there. And in terms of testing, AssemblyScript has its own testing libraries, but I can promise you it's like extremely solid. It's called Aspect. It's a Jest-like library written by Joshua Tenner. And if you've written Jest or like, it looks like JavaScript testing. It's like, you know, describe, it does that, you know, it should, whatever it may, expect to be, it offers all of that in AssemblyScript. So.
Right. And then so does AssemblyScript, so you write something in AssemblyScript, I know we were talking, so that is compiling it down. Is that using WASI? And then like, you know, what can I do? Can I pull in node packages in there, or does everything I do need to be AssemblyScript? Yeah,
I'm glad you asked. So what it ends up compiling to, it uses, so this is like really technical, but it uses this compiler backend called Binarian. And it's pretty much sits at the same level as LLVM, if you're familiar. So it uses their immediate representation to then compile to WebAssembly. So, and on the note of like using separate NPM packages, it would have to be AssemblyScript all the way down.
Gotcha.
So that is one thing that some people are like, oh, but my favorite image thing isn't there. And it's like, we'll have to port the dependencies too, which is, you know, kind of annoying, but the ecosystem is really growing. For example, I've been writing a lot of like URL packages lately for like URL parsing. And I saw we have the testing library. There's someone who recently wrote a JSON parser. So there's lots of little small things popping up. The community's growing, and it's all in NPM. So like, as long as you can, if it says like, hey, look, I'm an AssemblyScript package, you just NPM install it, and then it should work in your NPM project. And I think you asked one more thing.
No, I was just wondering if, again, if you had the same sort of access to some of the low-level things. So if you're compiling down to WebAssembly using AssemblyScript, are you then able, though, to do things like HTTP calls and access the file system and those sort of things?
Yeah, so that's what you'd ask about WASI. So yeah, essentially you would say, hey, import WASI, and then it'll give you access to those like FD read, FD write, and stuff. You don't have to directly access through file descriptors. Like, you know, another community project is ASWASI. It's kind of like sitting at the same level of Node where you import file system as like a whole word, and then it has like a create file, or maybe not create file, but you know, like read file, write file, whatever the API names are that I can't remember off the top of my head. But we do get into this interesting place. We have like a project in the AssemblyScript project that we're waiting for HTTP to be standardized in WASI for, that is just called AssemblyScript/Node. Because ideally, since, you know, the APIs are so similar, there's nothing stopping us from creating like a very like as close as to Node as possible API where you can start to just maybe copy paste Node snippets and they should just work because the languages are so similar. And one last ramble, if you don't mind, is
no, go ahead.
AssemblyScript is so similar to TypeScript that even though you can't take AssemblyScript code and run it through the TypeScript compiler, you can take AssemblyScript code, do some small tweaking here and there, and get it to run through the TypeScript compiler. So you can have the same source code, and let's say you're running in an environment for whatever reason doesn't support WebAssembly, you could just compile it then to JavaScript instead and call it a day, which is like kind of, I think, is a testament to how similar these two languages are.
Yeah.
So, yeah.
Well, that's portability too, right? That's really actually, that's kind of cool. So you mentioned a little bit about the ecosystem and sort of the community around it. I mean, that is a huge thing where, again, things grow when, you know, a Stack Overflow is a lot of people's friends, right? So if you can't get your questions answered there, or you can't Google for some of these things. So I know you said you've got, you know, the ecosystem is growing and you've written a bunch of blog posts and there's a bunch of other people working in this. But if I'm out there and I'm working on AssemblyScript, like, am I going to be able to find a lot of blog posts on this, or is this still very, very sort of early?
Yeah. So, I think it's probably like a little 50-50. Not like that it's that early. So I guess the reason why I'm saying 50-50 is because there's not like swaths of people in Stack Overflow. They're all AssemblyScript experts that can answer all your questions. There's definitely, the community is a little tighter. So, you know, we have a Discord server and we have a help channel that's like very active. Like if you want to have a question asked by the person that writes AssemblyScript, yeah, they're there, like almost ready to answer any questions. I'm there. Our team's about like 4 to 5 people. I'm sorry, 6th person that but you know, we're all there, and I check at least like maybe every couple, you know, whenever I have downtime at work, I'll check and see, is anyone asking any questions?
Right.
So there's a tight community on our Discord. In terms of blog posts, there's a lot of blog posts. AssemblyScript the only reason why I'm 50-50 there is because the project has grown really fast. So like there are some blog posts even that I've given that's like, hey, here's how you use pointers in AssemblyScript. Yeah, but not everyone wants to do that. Now it's we have a more mature runtime, garbage collection system and stuff. So your mileage may vary depending on like what blog, like there's a lot out there, yes, but like maybe 50% of them are still like very relevant to like the AssemblyScript you would write today. If that makes sense. Or maybe they're like, here's how you write your own JSON thing, but now there's a package for it. So like, we don't do, you know what I mean? So yeah.
No, that makes sense. Hi, everyone. I want to take a minute to thank our sponsor, Epsagon. Epsagon enables teams to instantly simplify, visualize, and understand what's happening within their complex microservice architectures. With their comprehensive, lightweight auto-instrumentation, users are able to eliminate the gaps in data and manual work associated with other APM solutions, providing significant reductions in issue detection, troubleshooting, and resolution times. Epsagon aggregates and correlates data from all the third-party tools you love, delivering a single pane of glass for understanding serverless, containers, Kubernetes, and more. Engineers now know when something is wrong and can immediately trace issues to root cause before they affect production. Increase developer efficiency and reduce application downtime with Epsagon. As a special for Serverless Chats listeners, if you try out Epsagon and connect your first trace today, they'll hook you up with one of their awesome t-shirts. Check it out at epsagon.com/serverlesschats. I mean, have people been using this? Like, are there some success stories here? Like, have been people successfully building applications with AssemblyScript?
Yeah, so if I might do the first one, so just going chronologically in my head, the first one, if I may, a little self-plug here, is that the reason why I got involved in the project was because I was really excited about WebAssembly when I heard about the predictable performance and like the Liam. I was like, oh, I got to get on this like ASAP. So one thing I like to do is build emulators because I think they're really good at stress testing any new technology because you need graphics, you need audio, you need to make sure that it runs fast enough, you know, things of that sort. So I'd built in a Game Boy emulator called WASM in AssemblyScript, and like it's really early days where I was just like pointers, memory, stuff's moving. But because it was a Game Boy emulator, like that's what you have to do anyways. And from that, it like we found a lot of bugs in the project and we worked through them together. And then that was probably like kind of how I guess maybe got known in the WebAssembly community early on. It was like, you're the dude that built the Game Boy thing. Nice. So that's probably the first one. Probably the most recent one I can think of as of recently in terms of like just general community is there's someone named Marcel Dwin. I hope I said their name right. But they work on like a storyboarding application. I think it's called MyCreo. And they wrote a whole article about how, you know, they were using JavaScript and kind of I think Canvas at the time and things like that. And they had taken all those hot paths, those things that like were computationally intensive and rewritten them in AssemblyScript and started using WebGL and stuff. Kind of just updated the application to like kind of modern day, but AssemblyScript was a huge part of that. And they wrote an article about like, yeah, I could read it. It made sense. It like, you know, compared to alternatives, I didn't have to like learn a whole new language. It was like, they had a really good experience with it. And I think I'm like 99% sure, just on the article up right now, but they shipped it to production and like their users are happy and they saw huge performance increases from just the nature of WebAssembly because they used it in the right places and things. So that's really exciting. And then probably more recently today, Fastly has been using AssemblyScript. That's one of our supported languages on Computed Edge. So we've had, you know, it's still in beta and we've had some customers try it out and we've had some really good feedback about it. And some folks really like it again because it's like, hey, look, I know JavaScript. This isn't too much of a transition for me.
Right.
Cool.
Right.
You know, thank you. Right. So that's really exciting. And then I know Shopify publicly announced they've been playing with AssemblyScript a lot. I know from being on the team, we chat with them a bit, but I don't want to get too into their business, but are not. You know, I'm very happy for them, but I would redirect you over to like what they've said, just so I don't say any wrong things.
Right.
Essentially. Yeah, but they're trying us out as well, which is really exciting and shipping stuff, if I'm not mistaken. So yeah,
awesome. So it sounds like WASM and WASI and all these things, AssemblyScript, all these things are coming together. It's growing. It's becoming more solid. Like you said, you wrote some blog posts where it was like really low level stuff and then you started building ways that make that easier. So I guess, there's still some limitations in here. It's probably not the right choice for everybody, but I'm excited about it because I think that it could change like a lot of things. But I guess, maybe since you work on this team and you're part of this ecosystem, like what's the future? Like where do you think this is going to go? And are we going to get to a point where, we can kind of use this for pretty much, just everyday stuff?
Yeah, totally. So the first one that I'd probably be most excited to bring up is this idea of nanoprocesses. So that's, sounds really flashy. So I'm not the one championing this. I'm not the main person behind this. I would very much redirect you to Lynn Clark's talk, who gave a talk about this idea, WASM Summit of last year. But from how I interpret it, nanoprocessing has this idea of that there's this concept of shared nothing linking. So for example, in the NPM ecosystem, if you have an NPM module that requires another NPM module, and this top NPM module is like, hey, look, I want access to everything that NPM or Node provides. And then this bottom module, and for some reason this module is like, I'm gonna throw some things on global because I feel like it. And then the bottom module is like, oh, that's cool. I'm gonna figure out some way to get required by this person. That way I can start accessing the things that I didn't have to require. Therefore, I look okay from a security perspective, but I'm taking advantage of some of the JavaScript-y type things that NPM allows. And that's, we've had a lot of like security, I guess, scares that they were valid scares because of like things in the NPM ecosystem, kind of because of this problem. So the idea of shared nothing linking is that in the future, we're hoping that WASM modules can import other WASM modules. From that, you have to declare, again, from the host call or whatever it may be, that like, I want these specific things. So we can figure out like, okay, when we run in the runtime, we know you only need access to file system. You don't need access to machine learning, whatever, crypto. You don't need access to that.
Right.
Your parent module has access to that, but you don't need it. So we're only going to make sure you only have access to those things, not everything that your parent needs, only what you need. So you start to, this creates a really good thing. So that way you're not like escalating out of NPM WASM modules to new WASM modules, because, you're really only linking what you need and not like the whole everything. If that makes sense.
Right. Yeah.
And another big one is interface types. Again, so we're already on this topic of like WASM modules, importing other WASM modules and, linking together and things. So, not every language is the exact, we talked about this language agnosticness of WebAssembly. You start to see a problem where it's like, well, Python strings are different from JavaScript strings that are different from Rust strings that are different from, Java strings. What do we do? So this idea of interface types. So pretty much a specification for like, hey, look, if we know, your language uses UTF-8 and this language uses UTF-16, let's figure out a way so that like when y'all talk to each other, there's not a huge performance cost that needs to be paid of re-encoding every single time y'all like go back and forth between each other. Or if you just take a string and you just pass it to a third WebAssembly module, we shouldn't have to re-encode it from like UTF-8 to UTF-16 to back to UTF-8. It should just go straight through. You know what I mean? So trying to like specify that and find a way where we can standardize that so that like WebAssembly stays fast in that regard of like passing memory around between other WebAssembly modules and kind of leading towards that like take it with a grain of salt, but that NPM-ness of like everyone just kind of like connecting these packages like Legos that build a bigger picture and a better structure using community and open source and things.
Right.
So yeah, and then let me try to think. And then probably
is there anything on performance? I mean, I know that performance is pretty good, but like any updates or ideas for performance?
So I'm so glad you brought that up. Thank you. So yeah, one of the big ones is SIMD. So my buddy, one of the champions for it, if I'm not mistaken, or one of the most involved people is Thomas Lively, and they give a really funny talk in which SIMD, what it stands for is single instruction, multiple data. And I like that. I can't explain it over video, but the idea is that like pretty much they're like, hey, we have this, we want to like, let's say, we have this 4 different, like a vector of numbers, like an array of 4 numbers, and we want to add them all to another 4 numbers. If we were to do that in JavaScript, we'd be like, okay, well, array 0 plus array 0 of this one equals the new array 0, array 1 of array 1 equals a new one. And then in their slides, they were like, but we have SIMD, we just add them directly. And it equals the new result. And it's faster because it took less slides to explain that than if you were going array 0 to array 0. So that's really the idea, is that like if you had a vector by, the mathematical terms, but like if you had an array of numbers and you want to add them to another array or do the same single instruction to multiple data, it just does it all at once. And you get lots of performance benefits out of that. So kind of getting that working in WebAssembly, it has like a ridiculous number of like different instructions to like, because you have to think like, okay, well, if I have an I32 that's 6 long versus like, it just creates a lot of WebAssembly instructions. I'm probably rambling a little too much. And then I had one more note, and threads.
Well,
threads is another big
threads.
one.
I was curious about that because I didn't ask you that earlier, and I'm just wondering, when WASM runs, is it single-threaded, multi-threaded? Like, can it do multiple threads? Like, how does that work?
Yeah, so as of today, WebAssembly is all synchronous and it's all single-threaded. In the JavaScript, I've given a lot of talks about this. if you use web workers, which kind of unlocks multiple threading on the web with WebAssembly, that is like the performance like chef's kiss. Like, yes, if anyone out there is building a computation intensive web app, web workers and WebAssembly is like a match made in heaven. But for a lot of folks out there that want to, maybe are porting over a larger C application, for example, Threads is like kind of just launching off Threads in WebAssembly itself is something that a lot of folks are excited about. If I remember correctly, Google, last Google I/O or Chrome Dev Summit or whatever it may be, VLC has been talking about a port to the web and kind of what they're doing there. And they're really building a lot of their port on top of WebAssembly Threads, which a lot of folks at Google are like kind of like doing a lot of specification work there. So it just kind of shows like, hey, look, now we can like watch, whatever random video format in the browser rather than only the supported ones using a VLC port. So yeah, and also, again, I'm not an expert on work at VLC, so we can do some Google searches, or I can send a link or provide more research later. But yeah, Threads is super exciting. So yeah,
right. And I mentioned earlier, this idea of like an NPM type thing, but like, is it possible? Because this is another thing where I like about serverless is that you can write one function in Python, and another function in JavaScript, and another function or Node, and then another function in Java or whatever. And of course they're isolated, so they don't have to necessarily run together. So you can use those different runtimes. But is that something that's possible? Like if somebody wrote a WebAssembly script in Rust and compiled it down, and then somebody else wrote one in AssemblyScript, are those able to kind of work together?
So that's the future we're definitely headed towards, and we're really excited about. There is a specification I mentioned earlier about the whole WebAssembly module requires another WebAssembly module. We're hoping with a spec called module imports, which more of we're working on it. So whatever it may be. But so essentially, you wouldn't have to have all AssemblyScript or all Rust. Once they compile to WebAssembly, then they can say like, okay, well, we're both WebAssembly now, so let's like import each other. It doesn't matter what our source code language was. So module imports is hoping to solve that problem. And once we kind of get more of these things standardized out while things are still young, that's kind of the future we're headed towards, of which like my dream thing, as seems like for you as well, is like, oh, I would, personally, I love all the work that Python does in the machine learning community, but it's just Python's not for me. Right. I know it. But I would love to access all the cool things they're doing over there.
Right.
But as a primarily JavaScript developer, I'm like, well, I'm gonna go play with DOM.
Yeah, well,
not to like downplay myself, but you know what I mean?
But that's interesting because that's the kind of thing where, think of like a global NPM, you know what I mean? Where it's like, it's just some functionality was built. And if you can pull that in to, maybe you're an AssemblyScript person because that's just that's what you're familiar with, but you can't make AssemblyScript do some sort of complex, crypto thing or whatever that maybe some other language could and compile down because it's either further along or whatever it is. Being able to share those across, cross applications and reuse those, that sounds pretty exciting.
Yeah, it sounds super exciting. Definitely, I think that's the future we're headed towards. As a community, we'll see what gets announced here and there and things. Again, there are some folks trying it out already, like kind of this idea, but we'll see. I really, again, also as you, very bullish on this idea of like, yes, we can like totally have this cross, like, it's no longer are we bounded to our languages. It's like we just write code and we can all be one large ecosystem. It's going to be awesome. Looking forward to it.
Cool. So I want to ask you one more thing, though. So like, let's say that I'm a developer, I'm listening to this, and I say, WebAssembly sounds amazing. How would I convince my development team, or more importantly, probably my boss, like how would I convince them, hey, this is something we should start investing in?
Yeah, I'm so glad you asked. The thing that's about WebAssembly that's really interesting, and I get asked this often, it really depends on what you're doing. Like we've maybe covered like, oh, you could do this, you could do that, you could do this. So it depends on what your area is. For web applications, definitely if you're building like an application that does computationally intensive things, like maybe you're working on like an online photo editor, whatever it may be. Maybe you're working on like a spreadsheeting tool where you have to do complex math functions. Just kind of like understanding really where WebAssembly fits into an application. That's where you can start to make the pitch to your boss. So if you're really excited about this right now, I would say I have some resources that I've built called WASM by Example, which is how you can get started with little bite-sized examples of WebAssembly. But another one is Made with WebAssembly. So wasmbyexample.dev and then madewithwebassembly.com. Made with WebAssembly is just kind of like a showcase of a bunch of folks using WebAssembly in production and side projects, kind of like pushing like, okay, well, what's WebAssembly good at? These are some examples. So if you can go and make WebAssembly and you're like, oh, my app does something similar to that, maybe you're on the right track. Maybe it's worth considering for what your team needs and things. So yeah, I guess really just understanding what WebAssembly is good at and then see how can we fit this into our application is probably your best bet, because then you can make a solid argument for why.
Awesome. All right. Well, I'm going to put all of that information in the show notes. I know there's a bunch of links that you have and all kinds of really good documentation and just good ideas, like you said, if you want to convince your boss or whatever to use it. So I'll make sure I get all that in the show notes. But Aaron, thank you for sharing this. This was super exciting because I just don't know enough about this stuff. So anytime I just love sort of learning this stuff. And I'm super excited about the compute at edge stuff. I think WebAssembly is such a great packaging format for that. But I'll put some of those other links you mentioned in the show notes. But if they just want to find out more about you, how do they do that?
Yeah, totally. Probably the best way to get a hold of me is on Twitter. So my username is Torch2424. Just as a quick, so people ask me why. I got on the internet really young when I was like 6. Torch was my imaginary friend. And then 24 is my favorite number. When my kid brain was like, it's better than 24. 24 twice. So
there you go.
Hopefully that story helps drive what my name. But yeah, I'm on Twitter most of the time. Probably reach out to me on Twitter. Probably the best. I'm trying to think. If you like,
I've got you. I've got your LinkedIn here. I've got your GitHub, which is Torch2424 as well. Check out Fastly.com and everything that your team is working on over there. And then I think you mentioned the Bytecode Alliance too, right? So that's just bytecodealliance.org. Probably some great information there. And then I'll get everything else in the show notes so people can check the stuff out. Give them some weekend reading to do. But thanks again, Aaron. I really appreciate it.
Yeah, thank you very much for having me. I super appreciate it. And looking forward to keeping in touch and things.
And that's this week's Serverless Chat. I want to give a huge thank you to Aaron Turner for being my guest this week and to our sponsors New Relic and Epsagon. If you want to check out the show notes and a full transcript of this episode, you can find them at serverlesschats.com/93. For more Serverless Chat, subscribe, sign up to be an insider, check us out on YouTube, and follow us on Twitter, Facebook, and Instagram. You can connect with me on Twitter at Jeremy_Daily, and if you want to keep up to date on everything serverless, make sure you subscribe to the Off by None newsletter at offbynone.io. Thank you so much for joining me, and I look forward to chatting with all of you again next week.